Hey guys, so this is the last video on nuclear issues, at least for a while, finishing off this topic of radiation and nuclear fusion, fission and all that stuff. So which are the issues or the things we need to consider when we're talking about using nuclear radiation for harvesting energy? So background radiation is one of the issues, radioactive risks, nuclear waste, the disasters at Chernobyl and Fukushima, and I said it right, and half-lives and instability, okay? So actually I'm going to start with half-lives and instability because the other ones I believe that I have slides for them. So remember that when you get a radioactive isotope and you get the fission, especially the fission reaction happening, you do decay into other products. Now, these products are going to be radioactive, and the activity of the half-life or the activity of the sample or the product that you get does decrease over time. However, sometimes they take millions of years to decrease. So you can get nuclear radiation around you for several thousands of years until you actually can, don't have the radiation around you. Now, why is this an issue? Because radiation does have some risks, okay? So now jumping into this part, does have some risks into your health. So I'm going to go in more detail when I show you the actual slides, so you can take notes if you want. And that has to do with the nuclear waste, of course. And then, besides of that, there are already radiation that we are getting every day. So that's the background radiation, which I have a slide as well. And do not forget that sometimes things can go wrong. Chernobyl was a different issue because they didn't have kind of the technology we have at the moment. And Fukushima, with all the technology that we have at the moment, because of a natural disaster, so a huge earthquake, there were some nuclear issues, and some radiation was also spread around over a wide area. So these are still issues that we need to consider, even if our nuclear power stations are amazing. After you watch this video, click on this one, so I'll put the link on the description. It's an amazing video on the most radioactive places on Earth, and then they compare the amount of radiation that you get in those places with bananas, because bananas do have radiation, so they are one of the most radioactive things you can eat. So that's a really interesting video, so I think you should definitely watch it. Alright, so background radiation. In our everyday life, we do get some radiation already. Cosmic rays, food and drink, medical, air travel, building materials, all these things, okay? And these numbers that you see in here are how many units of radiation you get per year as an average person, okay? Depending on your job, you can get more or less. So radiation is measured in sieverts, and these are the units of radiation that you get every year. So as you can see, natural radioactivity in the air is the one that actually has the most, okay? So that is where most of our radiation, where we are exposed, is coming from, okay? Now, this radiation is ionizing, so it's hazards. It has a hazardous, sorry. So it can damage, mutate or kill cells, and it can evolve into a cancer. So this is why it is an issue, okay? So, Chernobyl, let's think about Chernobyl. I do have a video in here. It's the Greenpeace video, so it does have some political message at the end. I never talk about my political views and any of these things, but it is a good video in terms of what happened, because it does have some interviews, some small extracts from interviews, and you can see how even after over 20 years, it's still an issue what happened in Chernobyl. So if you don't know about Chernobyl, the nuclear reactor in the Ukraine exploded. The nuclear reactor was using nuclear fission. The fire lasted 10 days. The cloud of radioactive materials spread throughout the Europe. More than, how many zeros? 1, 2, 3, 4, 5. More than 1 million people were evacuated from Chernobyl and the surrounding area. And it is still the world's worst nuclear disaster, and hopefully there's nothing worse than that. As I told you, the earthquake in Fukushima, if I said it right, did bring some nuclear fallout, but it was nothing compared to Chernobyl. We do learn lessons, and things were measurements were taken in place straight away, but is still being monitored, and it's quite recent. We don't know exactly the scale of the disaster. Okay, so do watch that video as well. So in the Chernobyl, can it happen again the way that it did? Well, now the nuclear reactors have a different design, so again it's trying to make sure that it doesn't happen again. Most reactors have a high-speed shutdown, which the Chernobyl reactor didn't. And also at Chernobyl on that particular day, because of some testing they were doing, the operators at Chernobyl, they did ignore some safety instructions, or at least we were told that this is what happened. Okay, and there are thousands of nuclear reactors in the world. They are working safely so far. So this is kind of a game of looking at the advantages and disadvantages. Even for me, it's very hard to have a very strong opinion, but basically if you're watching this video because you have a GCSE exam, it's not about your opinion if you are against or pro nuclear fission, I don't mind, nuclear fission, sorry. It's not about if you are pro or against fission, it's more about if you know how to weigh the advantages and disadvantages. So, there is energy demand. Fission is at the moment a great way for us to actually meet the base load, but there are issues, so it's about containing them and seeing what we can do about it, really. So, there are a lot of drawbacks as well. Now, what is the problem with the nuclear waste? In this particular picture, I took it from AQA. The fuel rods are very hot and very radioactive. After the removal from a reactor, they are stored in large tanks of water up for a year, and the water cools down the rods, okay? This is used by using remote control machines to open the fuel rods. Robotic arms do the same, okay, to manage the rods. The unused uranium and plutonium is removed chemically from this fuel that was used, and they are stored in sealed containers so they can be used again. The remaining material contains many radioactive isotopes with a long half-life, so I told you that there was an issue. This radioactive waste must be stored in secure conditions for many years, and this is what the biggest issue is at the moment, okay? Now, why is this a big issue? Remember this table with the alpha, beta, and gamma radiation, the penetration powers, what stops them, and the ionizing effect? Now, this is why it is an issue. They are all ionizing, especially alpha is the most ionizing at all, and this is going to have an effect in our body if we are exposed to the radiation. So the effect of radiation in our body depends on the type of radiation, alpha, beta, or gamma, amount of radiation that you get, whether if the source of radiation is inside or outside your body. Gamma is quite dangerous outside our body because it can penetrate our body. Alpha not so much because it's absorbed by few centimeters of air or paper. However, having alpha inside our body is really dangerous because it's the most ionizing. So again, you need to take that in consideration. Is the radiation outside or getting into your body? And the exposure time to the radiation, okay? So all of these affect your risk of getting a cancer or having a drawback from the radiation, so something bad happening to you due to the radiation. You can cut down your exposure to radiation though, trying to keep as far as possible from the radiation source. If you are handling any tools, use long handles, again, to be as far as possible. Spend as little time as possible in at-risk areas. You may have seen in hospitals when they are doing any exams where radiation is going to go to the patient, they give you these lead vests, not vests, but these plates for you to have, so to protect certain organs. They are not going to be needed to get the radiation, so you don't need you are not looking at those organs and you want to keep them away or trying to make that the radiation doesn't get there. And the doctors and the nurses, they leave the room as well. And if they are exposed, they wear a badge most of the times, and if the badge already shows that they had a certain number of radiation that they were exposed to, they actually need to leave for a while until the radiation measurements drop down, okay? Shield from radiation by using thick lead plates or going behind thick lead concretes or barriers. Again, this is most of the time when you are in hospitals. Now, you will never be exposed to zero amount of radiation because of the background radiation that is always present. And again, some food, cosmic rays, all of these, they have radiation, especially bananas, okay? So I'm not doing the exercises because this would be picking stuff from AQA, and I try as much as possible to give you stuff that is only mine. I only do it if it's like really something super amazing. So this is the nuclear issue, so you need to know about this stuff, and do watch those 2 videos, especially the most radioactive places on Earth. It does put things into a perspective. So up to my next video, be happy and healthy. Bye!